Students, today we will learn about structure of atom. We know that the Indian sage Kannada was the first to suggest that all matter is made up of very small particles called paramanu. In Sanskrit, parama means final or ultimate and anu means particle. Are the atoms of all substances similar? Do they resemble one another? Let us do an activity and understand and explain it. With the help of teacher, take a small piece each of sodium and iron. Drop them into a 500 ml beaker containing water. What do you observe? Which reacts faster in water? Now let us see another activity. With the help of teacher, take a small piece of sodium in a spatula. Ignite it. Hold a piece of magnesium strip in tongs. Ignite it. What do you observe? Which burns very fast? Is color of both the flames same? Sodium and magnesium are made up of atoms. Is the nature of both the atoms same? The above activities show that atoms of different elements have different properties. Any substance made up of the same type of atoms is called an element. 118 elements are known to us. Out of this, 90 are found in nature and rest are made in laboratory. Atomic theory. In 1803, English chemist Dalton put forth his atomic theory. Elements are made up of very small indivisible particles called atoms. All atoms of a particular element are identical in shape, mass and other properties, but are different from the atoms of other elements. Atoms of one element cannot be converted into those of another element. Atoms of an element combine in integral ratio with those of other elements to form a compound. An atom can neither be created nor destroyed. Fundamental particles. J.J. Thomson's experiment. Let us look at the history of discovery of the smallest particles inside an atom. J.J. Thomson and others conducted some experiments using discharge tube apparatus. In this figure, we can see the production of cathode rays. A discharge tube is a glass tube about 15 cm long and 3 cm diameter, connected to a vacuum pump. Metal electrodes are fixed to the ends of the glass tube. J.J. Thomson created a very low pressure inside the discharge tube and applied high voltage. He observed a greenish glow near the anode of the glass tube. The rays which are emitted from the cathode towards the anode are caused the greenish glow. The streams of rays emitted from the cathode are called cathode rays. If you connect the plate of the discharge tube to a positive source, then that plate is called anode. J.J. Thomson placed a light paddle wheel in the path of the cathode rays. The paddle wheel started to rotate. He concluded that cathode rays are a stream of particles. Now let us see the next figure. J.J. Thomson applied an electric field parallel to the path of the rays. The cathode rays deflected towards the anode. He concluded that cathode rays are negatively charged. Though J.J. Thomson conducted the above experiment with different gases, the same results were obtained. He named these particles as electrons and stated that These electrons are negatively charged particles. How are electrons and protons arranged in an atom? Rutherford's experiment. It was initially believed that electrons and protons are uniformly distributed. Rutherford conducted an experiment which changed the entire concept of distribution of electrons and protons in an atom. He directed high-speed positively charged particles called alpha particles towards a thin gold foil. He observed that most of the alpha particles passed through the foil without deflection. A few of them were deflected at very large angles from their original direction, and a few were even turned back on their path. Based on this experiment, Rutherford proposed a set of assumptions. They are: positively charged particles of an atom are held together in the center of the atom. It is called nucleus. Nucleus is surrounded by electrons. The volume of nucleus is small when compared to the volume of an atom. The nucleus is positively charged, which is different in magnitude for different elements. The mass of an atom is concentrated in the nucleus. In a neutral atom, the number of electrons outside the nucleus is equal to the number of positively charged particles in the nucleus. Rutherford noticed that atomic masses of different atoms could not be explained if only protons and electrons are present in them. He predicted that a kind of neutral particle with mass equal to that of proton must be present in the atom. In 1932, James Chadwick experimentally proved the presence of such particles and called them neutrons. Mass of a neutron is almost equal to that of a proton. They are present in the nucleus of the atom along with the protons. Isotopes. Atoms of an element with different mass numbers are called isotopes. Hydrogen has 3 types of atoms, that is H1, which is protium or hydrogen figure. They are 1H2, which is called deuterium, and 1H3, that is tritium.